Exercise 1.1, question 2. Before starting with the question, let us revise the concept again. Reflexive, symmetric and transitive. What do we mean by reflexive? For all A belongs to A, the pair AA should belongs to R. If 1 belongs to A, 1 comma 1 should belongs to R. If 2 belongs to A, 2 comma 2 should belongs to R. Then we say that it is reflexive. For symmetric, if A comma B belongs to R, then we interchange their positions. That element also should belongs to R. Then it will be symmetric. For transitive, if A comma B, B comma C belongs to R, this element should be common. If these two elements are belonging to R, then A comma C should also belongs to R. And when a relation is reflexive, symmetric and transitive, all three are there, then we say that it is an equivalence relation. Now let us start with question 2 of exercise 1.1. Show that the relation R in the set R of real numbers defined as R is equal to A comma B, A is less than equal to B square, is neither reflexive nor symmetric and nor transitive. So if it is given that show that, then half of the process is become easy for us. How? Because now we have to find out the examples, because we already know that they're saying that show. So we have to show that it is neither reflexive nor symmetric and nor transitive. So we need to find out the examples for which they are not reflexive, not symmetric and not transitive. So let us try. So for reflexive, I have found 1 by 2. Now here 1 by 2 belongs to real numbers, set of real numbers, because R is a relation in set R. Now 1 by 2 belongs to R, but 1 by 2 comma 1 by 2 doesn't belong to R. Why? Because 1 by 2 is not less than equal to 1 by 2 square, because 1 by 2 is 0.5, 1 by 2 square will be 0.25, that is 1 by 4. So it is not less than equal to 1 by 2 square. So it is not reflexive. Okay, for reflexive. Now for symmetric we will check. Now for symmetric, like here we have minus 1 comma 4 belongs to R. Minus 1 comma 4 belongs to R. Why it is belonging to R? As minus 1 is less than equal to 4 square. Right? Minus 1 is less than equal to 4 square. It is satisfying this condition. But 4 comma minus 1 doesn't belong to R, as 4 is not less than equal to minus 1 square. Yes, it is obvious. 4 is not less than equal to minus 1 square. So it is not symmetric. Not symmetric. Now transitive part is little tricky. We need to think a lot in this to find out the examples. So let us do it. Like 2 comma minus 2 belongs to R. Right? Why it is belonging to R? Because 2 is less than equal to minus 2 square. Also minus 2 comma minus 1 belongs to R. Keep in mind that this element should be same. So A comma B, B comma C belongs to R. Why it is belonging to R? Because it is going to satisfy this condition, that minus 2 is less than equal to minus 1 square. But this 2 comma minus 1 doesn't belong to R. Why it is not belonging to R? Because 2 is not less than equal to minus 1 square. We can see that 2 is not less than equal to 1, because minus 1 square is 1. So it is not transitive. So this relation is neither reflexive nor symmetric and nor transitive. Now next one is little easy as compared to this question 2. Check whether the relation R defined on the set this. Suppose this set is A. We will consider this set as A. Okay, we will consider this set as A. A is equal to 1, 2, 3, 4, 5, 6, as R is equal to A comma B. B is equal to A plus 1. So let us just first write R in roster form. If A is 1, what will be B? B will be 2. If A is 2, B is 3. If A is 3, B is 4. If A is 4, B is 5. If A is 5, B is 6. Now I cannot take as A 6, B will be 7, because these AB are from A and 7 is not there in A. So I should stop here. Now I have to check whether the relation R defined on this is reflexive, symmetric or transitive. So let us check here whether it is reflexive. For reflexive, any element I can choose from here, and I should check that whether it's pair belonging to R or not. As any element you can take as 1 belongs to A, but 1 comma 1 doesn't belong to R. 1 comma 1 should belong to R to be reflexive. So it is not reflexive. Now for symmetric, let us check for symmetric. For symmetric, any element you can take, like 1 comma 2 belongs to R, but we can see that 2 comma 1 is not belonging to R. You can see 2 comma 1 is not there in R. So it is not symmetric as well. Now for transitive, we need to take that pair in which something is common. Like here, these elements are common. So I am going to take these pair only. 1 comma 2 and 2 comma 3 belongs to R, but 1 comma 3 doesn't belong to R. So it is not transitive. It is not transitive as well. So this relation also neither reflexive nor symmetric nor transitive. We can see from here. And now we will have question 4. Show that the relation R in R, this R stands for real numbers. Show that the relation R in R defined as R A comma B, A is less than equal to B is reflexive and transitive but not symmetric. As I already told that if it is given, show. So it's very easy for us. Now we have to show that these two are reflexive and transitive but not symmetric. So for not symmetric, I need to find out the example. If I know the example, then I can write it and show that it is not symmetric. But they are saying that it is reflexive and transitive. Why it is reflexive? We can show that. Obviously, we know that any element will be less than equal to, because equal sign is there, less than equal to itself. So A comma A belongs to R for all A belongs to R. So for all A belongs to real number, obviously this condition is going to be satisfied. A is less than equal to A. So we will have A comma A belongs to R. Now for symmetric, I will do for transitive first and then we will find the example for symmetric. Now for transitive, we know that if A is less than equal to B and B is less than equal to C, then obviously A is less than equal to C as well. So A is less than equal to B means A comma B belongs to R, and B is less than equal to C means B comma C belongs to R, and A is less than equal to C means A comma C is also belongs to R. So we will have A comma B and B comma C belongs to R implies A comma C belongs to R. So it is transitive, it is reflexive, but it is not symmetric. So for that we need to find the example. So for symmetric, we will have, we need to find any example. For that it is not symmetric. So for symmetric, we need to prove that A comma B belongs to R, that is A is less than equal to B, but B is not less than equal to A. So for that example is very simple. 2 comma 4 I can take. Okay, I can take 2 comma 4. Why I can take 2 comma 4? Because 2 comma 4 is definitely belonging to R, as 2 is less than equal to 4, right? As 2 is less than equal to 4, so 2 comma 4 belongs to R. But 4 is not less than equal to 2, right? But 4 is not less than equal to 2. So 4 comma 2 doesn't belong to R. Means 2 comma 4 belongs to R, but 4 comma 2 doesn't belong to R. So it is not symmetric.